equal to G inverse of x plus k is a tangent to F. Determine the coordinates of the points of contact between H and F. So there's two ways of doing it. One, by finding out the derivatives and then equating it to the gradient of the graph. Next, we can also find the discriminant. So let's first do the derivative of f of x. Let's expand everything. And that becomes nine over two. Right, so let's derive that. Now we take the exponent times it by the coefficient. So 2 times a half, we have just 1, so it's 1, and then you drop the exponent by 1. And then it's just here we have 1 times 5, which is just 5, and then drop the exponent, we get x is to the power of 0, so then it's just 5 here. Now let's write down what h of x is. Remember, we found out what G inverse is. It's 2x minus 9. Now, since this is a tangent to f of x, we can see that 2 is the gradient of the line of the tangent, right? So therefore, we equate x plus 5 to 2. Here we get x is 3. And then now we can just substitute x is equal to 3 back into this line, f of x. And you should get that y is equal to minus 6. Now there is another way of doing it, is that we find the discriminant. So we first say that f of x is equal to h of x. Move everything over to one side because it's a quadratic. Okay. Now remember, we're looking at a tangent, therefore we know that it is equal to 0. And the discriminant is b squared minus 4ac. So to find x, let's just do the quadratic formula. It's b squared, minus b plus minus square root of b squared minus 4ac divided by 2a. So we can just ignore this entire part because it is equal to 0. So minus b, it is minus 3 over 2 times a half. And that gives us minus 3. Now y would just be substituting this x value into our f of x. Half of 2 squared is 2, 2 minus 8 is 6. So x is equal to minus 3 and y is equal to minus 6. So therefore the coordinates of the tangent would be minus 3 and minus 6. Awesome.